How close are we to actually using materials in space to do the manufacturing, or how long are we still going to have to ship everything up to do the printing?
Yep, pretty interesting question, because the answer I think is interesting too. So in NASA acronym land, they call this in situ resource utilization, or ISRU, and historically that idea is, how do you take like the dirt from the moon or an asteroid and turn it into something of higher use. What we started to work on a couple years ago, and now we're getting ready to actually fly this to the space station, is a device that takes the plastic waste on the space station and turns it into filament for the 3D printer. So it's in a way like a recycling system. And that actually probably is the lowest bar of ISRU that we could come up with, which is taking a resource in space, plastic trash, and turning it into something more useful. So that's happening now. We're doing that. But I think the bigger part of your question is, how do we build that giant antenna I showed out of an asteroid, right? So I think it's still a little ways off until that happens. You have to kind of track, the asteroid mining companies or the moon mining companies and follow that path. The bigger answer is it's when it's actually needed. So today we can actually afford just to launch the material from Earth, and we'll do that. When it gets to the point where the thing we need is maybe too big to launch all that material, or just economically would be better to do it, then I think there'll be a transition where everything starts to come from space. And at that point, the moment that happens, I think we'll be sending more things from space to Earth than from Earth to space.
The question was, is there any advice we could give? Caterpillar has a relationship with Uptake, and that's a startup company, again, working with a very well-established old company. Is there any advice we could give about how to do that better? And it would be an interesting, if Brad Keywell were sitting here next to me, he definitely has a strong perspective, because there is a lot of clashing that goes on just in speed alone, in decision making. At the CAT side, you kind of have to go through. We're a very consensus-driven company, so you tend to have a lot of people in the same room. And on the startup side, you're used to just making those decisions. So I guess I'd say just first of all is awareness ahead of time that culturally there is going to be that clashing. So just get over it, and move forward and recognize that that's just a part of the process. And like, John Hagel talks about, you really do need to protect that. So separate it off so that the group, the people working on it, even the CAT folks that are working specifically on that, don't sit with the rest of our analytics division. They're in Chicago, we're in Peoria, so put some distance between there. So I think that really does help in keeping that separate, and also the fact that the two sponsors of kind of that initiative overall are our CEO and our Vice President of Marketing and Digital. So that really helps as well. I don't think anything like this would be successful kind of from a ground up approach. It really does have to have that high level sponsorship. They're very separate. It's actually we've bought into that company, so it's not a Caterpillar company. So they're not in our HR systems and our processes and tools. It's very much a separate company with Caterpillar people kind of seconded to that business, along with Uptake's own organization that they've hired separately. Not at this point in time. There's not. There is kind of a middle ground there. So there's what Uptake's doing, and then there's what CAT inside our own analytics, and we're doing some amazing stuff within the CAT structure in the analytics area as well. But at this stage in the time, there's not a plan to merge those.
On 3D printing, first thing, there is still some limitations when it comes to, let's say, pressures and temperatures and stuff. So the material properties are not yet there to replace everything. So where do you see this moving? Will we have something like a Murphy's Law in terms of development, that it will go quicker and quicker and get better and better? And secondly, do you see the printing technologies displace current tools for serial manufacturing? Or will it always be an on-demand kind of thing that for very special purposes?
I think that well, in the case when you were talking about in space, it's okay because you could just pay a lot for a metal 3D printing machine or something like that. I think that one of the most dramatic things is when people start caring a lot more about time, then it's okay to deal with machines that might be more expensive, like 3D printing. When you can't wait for something to be shipped halfway around the world, you have to make it locally to you, and so you're kind of trading the fuel cost for the cost of the machine to make that. But we're already seeing, like high temperature polymers being 3D printed, or even titanium being 3D printed with like selective laser sintering of metal powder and stuff like that. So I think that there will always be big manufacturing for making a certain class of things, but as the level of customization and the batch sizes get smaller and you care more about time, then the 3D printing type of manufacturing technologies will be more competitive and more widely adopted.
Yeah. I would add just like kind of personal anecdote from what we've been doing, because I totally agree. I think that a lot of companies today are just trying to like make some parts be 3D printed in whatever it is they make, just to say they're 3D printing a part of the thing that they make. I think what's important is like you use 3D printing when that makes sense. Use a CNC when that makes sense, or whatever it is. For us, we built a 3D printer for the space station because what we were trying to give was astronauts the ability to get things quicker than they currently could get it. And it just turns out that a 3D printer is one really wonderful way to do that. And why that's so important is that before they had the 3D printer, they had to use whatever else was there, right? So there's this wonderful story of an astronaut, Sunita Williams, is on a spacewalk. She needs a tool that just doesn't exist. She's trying to fix a power supply. She goes back in to the space station and fashions the tool out of her toothbrush and some duct tape. So they're just using whatever is there to make the thing that they need. And that tool is a great example of something that could have easily been 3D printed and would be better than a toothbrush and duct tape. And so when all you have available is duct tape and the other things there, then the printer becomes really helpful. And so we're looking at like where there's so many other environments on Earth like that, where you're extremely remote, you're cut off from the supply chain. You can't go to the Lowe's down the road. You have to build it there. And I think that's where you start to see some really good use cases. But then also, I mean, the materials are catching up, and I think more and more can be 3D printed.
Hi, this is a very specific question. If I want to, let's say, create like a maker space that's good enough for people to tinker with, is there anywhere, I don't know anything about engineering, manufacturing, it's not my area, but I think it would be cool to have a maker space where people can go tinker. Is there anywhere we can go to access like a list of things to have?
Yeah. Oh, I don't need one. Yeah, just email me, Danielle@othermachine.co. There's a couple lists. There was one that was even put together by a California Association of Community Colleges that was interested in putting a lot of makerspaces. They did a ton of reviews of things that are in a makerspace, but not only things, but like best practices for makerspaces. And there's also like makerspace playbook and stuff. So just email me. I'll email you a list of stuff.
My question is around the role of enterprise software in the future of manufacturing. So there is a transformation going on right now in the area of manufacturing, traditionally big manufacturing companies like Caterpillar. So what role these ERPs and PLMs will be playing right now? And once this transformation is going to go into a more mature state, what would be the role of ERP and PLM for future?
That's a great question, and I think it's a neglected question, at least at this stage in the game. A lot of the focus, and I can speak for Kat, when we look at disruptive technologies, you tend to look customer back, and a lot of them are about kind of that interface. But within our company, and specifically with PLMs and ERPs, anybody that's ever tried to go through a transformation in that space knows how remarkably painful it is to upgrade or to integrate or anything with these old systems that we have in place and trying to replace those. I think that the nirvana in that space would be having a quote-unquote Internet of Things environment within our factories, where it really doesn't matter if I've got this old ERP system over here and this old PLM thing over here and this brand new thing, making those things be able to talk to each other without having to go in and wholesale replace them would be would be ideal. I think also what we found out in uptake would be, they found that, when you're working with a well-established company like CAT with scads of data and decades worth of information and data at their hands, but it's a lot harder than it sounds to come in and integrate with these older ERPs and PLM systems, and especially if you have like for instance a CAD, our PLM is different than our CAD tool. So our CAD tool is one company's software, our PLM is another one. So we've already kind of patched them together with interfaces between one vendor's this, that, and the other thing, and so we don't have that kind of beautiful flow of information. And then you come and you want to do stuff on top of that. You want to put layers of apps on top of there to be able to use this data, and it's just a lot harder than it looks. You think, all you smart people out there, you need to think of a way to be able to make these ERPs and PLMs and whatnot sing together, just like if you're mashing up something in some other IoT environment. But it's I think what slows us down, and what a new company doesn't face, because if you're starting with a clean sheet of paper, you can pick the right things, make them sing together from the beginning, and you don't have to worry about that. But when you've got 90 years worth of stuff around, and we're still looking, for COBOL programmers and stuff to come in and help us fix things, then it does make it more challenging. So we haven't found an easy answer in that space at all. It's just hard, long work. It takes a decade to change out some of this stuff, and you get the younger folks. Well, why is that? Why is that so hard? That shouldn't be that easy. You're just changing this and that. Well, it is. So.
For us as a small manufacturer, we have, each machine has 300 parts. We have 50 suppliers. It's like we don't build, very many a year, like less than 5,000 units a year. So we had to create our own ERP system. It was basically because they're either huge and they have too much stuff for you, or it doesn't do enough. It doesn't, there's no gap accounting. Nobody thought about gap accounting when they made it. And so there is this middle region, especially as we see more smaller manufacturers get started, that there's a huge gap there, a huge opportunity. I mean, it depends on how much you believe in small batch manufacturing taking off, but there's a really big opportunity, especially to focus on the data. Like you said, for us, we didn't have enough time to do enough testing really to be confident in our products. We had to track every single part, how much it cost, who put it together, what was the time that it took together, what was the QC of each individual part, and create a web-based system that would track all that data, because nothing was out there. But if there was something out there, I would pay thousands of dollars a month for it.
I laugh. It's called a spreadsheet. I think
basically.
we still run the bulk of most things on spreadsheets.
Jason, on the large-scale ships in space, large-scale manufacturing platforms, what is the opportunity there, really? Is it the fact that instead of sending one satellite into space on one rocket ship, you can now send the materials for, say, 20 satellites to the platform to then make 20 satellites on one payload? Is that in the realm?
So there is a very large variety of things that we will build in space, and when we can build very big things. One great example is just building big antennas. Today, the global communications is built upon the ability to have satellites in space to do communications, and those antennas are a certain size because they have to fit into a rocket. Some of them are just a solid antenna, so it's the diameter of a rocket. Some open up like an umbrella, but either way, they're limited by the rocket in some way. So a bigger antenna is better. It requires less power, or it gives you more bandwidth and so on. So that's one classic example. There's a lot of other just really interesting ideas, the ones that we've never been able to do that mission because is always you can't fit it into a rocket. So that one picture I showed of classic satellite, and then the next thing was a big platform. That's an idea for a very large base station in orbit that becomes a shared resource. So on that base station are essentially all the parts of a satellite that don't advance with Moore's law. So an antenna is just governed by by physics, the aperture. So put antennas on the platform. Solar panels, maybe that changes Moore's law, but if you can build a nice solar farm, and so on. So you basically build this huge platform that in a way is like a spacecraft. It is a spacecraft. And then all of a sudden, everybody who's making these small satellites can just launch them and plug into that platform and share time on that resource. So if you wanted to start your own ComSat company and that platform existed, you could create that company with a very small investment, little satellites that only have in them kind of like the Moore's law technology, the computers. Fly it up there, rent time on the platform, do what you need to do, and then pop off. So I think we'll see some kind of really interesting new types of missions happen as soon as you can just build the big things there.
You talked about how engineering, it would be odd to think that one day people were engineers. I was wondering if you could talk more specifically about the state of the software, the generative design, and like where we're at with that, and what kind of parameters you could feed it currently.
So are you an engineer, Bruno?
No.
Okay. I think it's like a fascinating kind of thought experiment that's probably where we're headed. So today there's already a lot of really interesting things. The example I put on the screen was from Autodesk, from their generative design software. That was it's actually a chassis for a race car. And what they did was I think if I get the story correct, they had a car, they instrumented the car with a whole bunch of sensors, and then they put a driver in it. They had him race around the track. They gathered a bunch of data about just how the car performs, and that data went into an algorithm to explain kind of like some aspects of like the race car environment. And then the car was evolved just from those like inputs of like, here's the environment, plus here's the shape of the driver. So it ends up becoming this like form-fit race car for this one person. So I think there's a lot of kind of really interesting stuff already happening. We're doing that on the space side, saying, here's the constraints of a problem. We just need this type of structure. And the software is anywhere that you're like optimizing for like stiffness over mass or strength over mass or those types of optimization parameters, the software is pretty good at it. And you get, you can look up what Autodesk is doing. They have some really cool stuff that they're public about, but it's, leveraging the cloud allows you to do like a huge amount of design. I think we will have engineers that they come in the morning and by lunchtime they started the design of a skyscraper at 8 a.m. and by lunch they have a dozen different skyscrapers to choose from.
What's interesting about it too is it helps you unhinge your assumptions. Like if you're thinking, oh yeah, we've been doing it this way and shipping to space for a long time, but then you're like, oh well, this computer came up with a totally different way. I mean, it's actually the same as the kind of Go playing AI that Google made. Like the way that this thing won was doing moves that a human would never come up with. Same thing is true in CAD.
Yeah, it's exactly right.
I think the difficult part about that, though, is the change management within an existing organization. Because it comes up with different solutions, because you're trying to feed it true parameters, not parameters that are shaped by my own history. It's just it's very difficult to do, especially for an experienced designer, experienced engineer. It's a very difficult thing. It's almost when Jeremy Howard said he's a philosophy major. Now he's this math. I think you need that even when you're talking about generative designs, because the engineers are going to come in with a very prescribed set of paradigms about what something should look like or should end up being, and the generative designs don't come out that way, and you're thinking that's not going to work. So it's a change management exercise within an organization too, to make sure that those types of things can be successful.
In the space of manufacturing, and for the manufacturers, you have a new product introduction rate, which takes sometimes years to come in. How do you predict future? Because the user base, the consumption 3 years, 4 years down the road, it's totally different than what the parameters today, which forces the design and manufacturing initiatives. So how do you predict that 3 years, 5 years down the road, when the product will come out, it's going to serve the purpose which is intended to do?
I think that's probably in our sector. If let me separate our machines from the energy side for a minute. On the machine side, it's probably the clock speed of our industry is a little bit slower overall. So certainly our new product introduction cycles are slower, but because the equipment lasts so long, you know, the average life of a piece of CAD equipment is 19.8 years or something like that. And so that's the average. And obviously there's very long tails on the side of that curve. And so the function that machine is actually performing doesn't change substantively over the course of that time. But what you do want to be able to do is continually update it to get better fuel economy. For example, fuel economy is a hugely important factor for our customers. So what you want to do is try and design in enough flexibility, like we've talked on the software side, to be able to tune that machine over the course of its life without having to rebuild that. So the emphasis in new product introduction needs to be around making sure that we design a physical machine, the physical asset that can get the job done, that's the most reliable, the most durable, et cetera, but it also becomes a platform on which we can update as we learn more about how to better drive efficiency into that machine over the course of time. So it's kind of like on a much bigger scale, it's the same dilemma we do with anything. How can I issue a piece of hardware and just put software updates on it to respond to those changing market needs?
Are you specifically asking how do we improve the transportation up and down?
Correct.
Okay. Yeah. It's a good underlying kind of problem that we have to think about. So, actually, the reason why we're publicly doing this fiber as the first project of what we call manufacturing in space for Earth. The reason we're doing that one first is because the market for this type of fiber on Earth today is already a large enough market, and the kind of the cost per kilogram is high enough that we can still launch this material into space, reprocess it into fiber, and bring it back and sell it. So the problem is transportation to and from space is still a costly exercise, so there's not many products that can be made in space and brought back and still turn a profit. That's why we're doing the fiber first. So I think the best kind of the hope that we have is analogous to what's been happening with small satellites. So for anybody out here, who's been following this, there's over the past maybe 5 to 10 years, we've seen the size of satellites dramatically drop to this size footprint called a CubeSat. It's about a 4-inch by 4-inch cube. And the reason a satellite can be that small now is because everything in a cell phone is essentially a satellite, so you can make small satellites. There's a lot of companies now that are building CubeSats, and they're replacing legacy satellite architectures that were, the big satellite buses with small ones. Now, it took first the satellite industry to go small before the next thing happened, which is a whole bunch of new companies came about over the past 5 years or so to build small rockets. And the rockets are launching we're not even seeing them online yet, but they will be launching the small satellites. And it's because if you own a company and you want to launch 20 little satellites to build a little constellation, you don't want to launch a giant rocket to get your little guys up. So you buy the little rocket. So it took we had to show the industry that there was a market for small satellites, and then the small satellite rockets came about. So I think what will happen is we'll show that there's a market for making things off Earth and bringing them back, and we'll do it with what's currently available. We'll launch on a SpaceX rocket to the space station and come back. But the moment the industry sees that there's a new market available, I think what we'll see is the transportation companies, the launch companies will see themselves as transportation companies, and they'll all of a sudden say, hey, if I can make my capsule come back to Earth, I can address an entirely new market. And then the problem you're pointing out, which is probably the big elephant in the room, will quickly vanish.